Everyone, welcome back to Cis Theta Learning. We have been learning about RPC in the previous video. So as I mentioned, I'll take a diagram and explain you the steps in detail. So this is what we say RPC workflow diagram, and let's understand it step by step. And all credits to Geeks for Geeks. I've taken this diagram from their website, and now that we have understood what RPC is conceptual, right? Let's see what actually happens internally when an RPC call is made. Because from the programmer's perspective, it looks deceptively simple. You write something like maybe you want to say get player data. We saw, right? We have been using this name. Maybe get player data 101. And somehow when you write something like this and somehow the data comes back from another machine across the network, feels almost magical, but internally there are many moving parts involved. So let's break it down step by step. So an RPC system mainly has three components. What are these three components? If you see, this is the client machine, then you have okay, let's go into these details later. So RPC system mainly has these components, and so first is this client machine, right? This is the client machine, and it has three things in it. One is what does it have? Client. Then it has this client stub. Then it has RPC runtime. Similarly, now there is server machine here, server machine, and it also has three things. What are those? Server stub, RPC runtime. These three things. Now let's say suppose this client wants to call this get player data 101, right? So this is the first step. See, if you see here, client wants to call this, right? So let's write 1 here. So the client initiates this call normally, almost like calling a local function, and this is the important part. The programmer writes the code as if everything is local. That's the abstraction RPC provides. So now next step is, now it has called, now the call reaches something called the client stub. Think of client stub as a translator, because networks cannot directly understand functions, objects, variables. Networks only understand bytes, right? So client stub converts the function parameters into standardized transferable format. This process is called, we studied this in the previous video, that is let me write it here, marshaling, right? We started marshaling, unmarshaling. So yeah, so the client stub converts the function parameters into standardized transferable format, and this is called marshaling, right? So maybe marshaling, and now next is this was the next is, now the black message is handed over to RPC runtime. So this is the second. It is handed over to this RPC runtime, and the runtime handles actual network communication. If you see this, it handles the actual network communication. This includes this is the, if you see this, message transmission is there, and retries if there are acknowledgements, encryption, retransmission, everything. So developers don't manually handle socket programming every time. That is why we have this. This is honestly good, right? Because debugging a raw networking at 2 AM is what we say, a spiritual experience. So now network transmission. Now the client RPC, this client RPC, right? This is client RPC, this is server RPC, please, and this is client RPC, and that is server RPC. We are at client RPC now. So the client RPC runtime sends the message across the network to the server. So it sends it here. And if this is a synchronous RPC, the client thread waits here, right? We have studied what that is. So see this sending, let's call this step 3. We are here now. So request is sent, and there is waiting, and it will wait until the response is received. The waiting time is one reason latency matters so much in distributed systems. So now let's come to this RPC runtime. RPC runtime, this server, right? This RPC runtime, it receives the message, the server side RPC runtime accepts the network message, and it forwards it to the server stub. It forwards it here, server stub. So let's call this step 4, right? So it's server stub, and now the server stub performs the reverse operation. What we did, marshaling, right? There in the client we did marshaling, here we'll do unmarshaling. It extracts the parameters from network message. This is called unmarshaling, and so once it unmarshals, it will be getting this, and now the data becomes usable again, and finally the server stub calls the actual server. So this will be step 5. It calls the server stub calls the actual server routine locally. So this is our goal, right? We want to call a routine which is there on another machine. This is our goal of RPC, or what RPC does, right? So now the server, it executes. Now the actual server logic executes maybe it queries the database, it may validate the data, processes business logic, computes responses, whatever it is. And that once the execution completes, the result is returned back to the server stub. So see here, once whatever, see if you have this execute, whatever that is, then this is returned to server stub. This is step 6 now. Now the server stub again converts the response into a network friendly format. And again, what happens here? We did see here we did marshaling, here we done marshaling, again we'll have marshaling here, right? So now the server stub again converts the response into network friendly format. Again marshaling happens, and the response message and this is packed response is handed back to this RPC runtime here 7. And the server RPC runtime sends the response back to across the network. So this would be step 8, and sends the response back to across the network and the client RPC. And now once this is there, it will be received in. So the client RPC here it will be the client RPC runtime receives it and it passes to the client stub. It passes here. So this would be 9, right? And finally the client stub unmarshals again. So see, you did a marshaling here, you did an unmarshaling here, you did a marshaling here, again you are doing an unmarshaling here. So unmarshals the response, so it reconstructs the usable data from network bytes, then the execution returns back to column. So from the programmer's perspective, let's call this 10, right? Yeah. So you did something known as let's say player, let's say p equal to, this was what you did, looks like almost adding to a normal function call, but internally we had serialization, network communication, waiting, message handling, retries, all happened underneath at the hidden complexity. So that's the hidden complexity, and that's exactly why RPC is considered a powerful network abstraction. And honestly, this is one of the reasons distributed systems feel deceptively simple at a high level, because frameworks like RPC hide enormous networking complexity behind clean interfaces. So in the next videos, we'll continue exploring more distributed system concepts step by step. Also, if you want the notes and diagrams used in this video, let me know in the comments and share them as well. If you have any questions, if you need any improvements, please let me know. We'll implement those. So thanks for joining. I hope you had a great session of RPC. We'll catch you in the next video. Thanks for joining. Bye. Take care.